All right, welcome everyone. Thanks for joining us for our second session tonight. This one by Keith Fong. I heard him speak recently. I don't remember which section it was, but it was a great speech. And so I thought we'd try to get him to join us. I'm not going to go through his bio because you've all seen it, I would imagine, as part of signing up for the session, but certainly his qualifications as a excuse me, as a master black belt and a Shane and Red X master say he's been there, done that when it comes to problem solving. I found his background interesting in that he had started out as a design engineer and now is involved in continuous improvement. And so, boy, that's a big jump, Keith. I wish we had more design engineers doing that and then switching back and forth between those two roles. It would change the world, I believe.
I think you've got a strong point there.
Yeah. The other thing I found interesting is his role with ASQ. He's been involved with leadership of his local section and perhaps other roles for quite some time. And so I asked him, what would you have to say to people about that? And he said, one of the issues is being on the leadership committee has created a number of friends through our shared interests in quality in our local community. And so any of you who need some friends or want some friends, I'd encourage you to get involved with your local ASQ section, regardless of where you're located. It's really a lot of fun working with people like Sandeep and Arvid and so on. So Keith, I'm going to close my mouth and mute myself and let you go at it. Thank you.
All right. Well, thank you very much, Duke. I was actually a little, surprised that I was invited to talk about root cause analysis when, Duke has written such a good book called Root Cause Analysis. So I hope to provide a different, some different insights as we go through this. So this particular presentation is called Becoming Sherlock Holmes, the Process of Elimination and Root Cause Analysis. So I want to start with, I think, a really pertinent quote from actually one of the first novel of Sherlock Holmes, The Study in Scarlet, where he says, a conjurer gets no credit where once he has explained his trick. And if I show you too much of my method of working, you will come to the conclusion that I'm a very ordinary individual after all. And, through all the different stories, more and more gets laid out that it's, he uses observation and abduction and induction and deduction, right? He is, Conan Doyle wrote him as a guy who's kind of at the leading edge of his, the technology of the time, fingerprints and, chemistry and so forth. So, but all of that's in the service of a particular approach, right? Where we're going to go and gather information. We're going to look at, this data. In his case, he's looking for criminals or he's trying to solve mysteries. In our case, we're trying to figure out the mystery of, okay, what is causing the performance of my product or my process to be unsatisfactory. So, for this presentation, I want to just say several givens, right? One of them is that everyone is a problem solver. And I think this is really important to point out because, for us as coaches, I think most everybody on this call is in some way related to quality and helping promote quality. And that is, when we're working with people who are maybe not good at, say, root cause analysis, at the same time, they are getting problem solved. All of us have jobs in some fashion, or when we have jobs, it's like because we're helping solve problems. But, we also want to help raise the level of that problem solving. The next given is y is equal to a function of x, right? So in this case, I've written it out as x1 to x2, x3, all the way to xn as n goes to infinity. And my point here is that whatever output you get, whatever outcome you have, it's the result of multiple inputs. Now, that doesn't necessarily mean if we have a dissatisfactory output that it's the cause, it's a result of all of them together, because that's actually not the case, which gets us to the next idea. And that is, the Pareto principle. Many of us know this as like the 80-20 rule, or, the vital few, the I guess I hate to say trivial many, because I don't think it's true, but the necessary many perhaps. But nonetheless, the Pareto principle has the force of law, because when we have a problem, there is a cause, there is a principal contributor to that problem. And that's what we're looking at. Yeah, there might be a lot of enabling factors, but there is a principal root cause that we're trying to bring to heal. So the first thing I want to talk about is, what is a problem? So we're all on the same page about that. And to me, a problem is the difference or the gap created between expectation and reality, right? We want a certain thing and we have something else. And the nice thing about this kind of definition for problem is that it isn't tied to specification, because specifications, having been a product design engineer, I know that, any even the small drawing for a component has 25 or 30 things on it, and not every single thing has been thoroughly vetted. So you can say, oh yeah, everything meets the specification, but still the output, the function that you're trying to achieve is not satisfied. Okay, so again, a problem is between the expectation and the reality, and that gap, and the severity of that gap is the problem. Another way to phrase that, going back to our little equation, right, is we have an expected y, right? So y expected versus y actual, and that difference is a delta y. And what's important to us here is if there's some x in that equation, which is at one level with the expected y and at a different level with the actual y. And that's what we're usually, in the search for. And, we could say, hey, I'm, talking about expectations. You say, hey, I'm expecting my dinner to be a lamb chop like this. And then what I get is, a couple pieces of toast. Not that there's anything wrong with toast, but, it doesn't necessarily have to be bad that you can have a problem. Again, it's the gap between the expectation and the reality. Now, how do you solve problems? Because again, everybody's a problem solver. One way to do it is to reduce expectations. Now, nobody likes that as an option, because we want what we want. And I think now in this pandemic age, and you look at things like you want to buy something, it takes longer and it's more expensive, right? This is, so at this moment, you don't really have a lot of choices to get everything that you expect. I guess I was just seeing that one of the big problems with home building is a lack of garage doors. They can't finish them off because of all those supply chain issues. So, they're reducing expectations in some case by replacing garage doors with temporary, plywood enclosures. I mean, if the local cities will allow that. But, again, reducing expectations is one way you could solve a problem. Again, nobody likes that. The other way, hey, let's improve reality. But this can break into two things, right? You can have a short-term improvement in reality. And by that, I'm talking here like Band-Aids, and we've all seen it, right? Where we'll do a containment, we'll sort material, we'll double check things. The problem is that kind of creates a time bomb, because we're not actually fixing the problem, right? We're basically just alleviating symptoms. And this can become the job itself, right? So I'm sure that you all can find examples where, well, in fact, this happens for all of us who work in the office, where somebody has to review a report before it gets sent out, right? And what is that? Well, that's just an inspection, that's to prevent some kind of problem, but it's not solving whatever the problem was originally. And so, people can turn this into their regular job, where they think, oh, it's my job to go and inspect. It's my job to go and do corrective actions. But in the simple truth is that no, you're just addressing symptoms. It is problem solving, but it's not actually making reality truly better. It's just stopping it really from getting worse. And this is such a common thing that, we have terms of, we have phrases that we that are very common, right? Like sweep it under the rug, kick the can down the road, right? This is like, we're not dealing with this problem. We're just kind of getting by. So of course, we're a bunch of quality people. We are long-term thinkers, right? We want to be in there going, hey, what do we need to do so that if there's a problem, it's resolved and doesn't come back? And that drives us into root cause analysis. So I want to make a comment here about some really common problem-solving frameworks, like the Six Sigma DMAIC, the Toyota A3, the Ford 8D. These are all basically the same. I've through my career, dealing with a lot of different customers, and just out of curiosity, looking at what other folks are doing, we see all of these. It feels like every company has their own twist on some version of these documents, and that's all well and good. But these frameworks don't actually do the problem solving, right? I would call them more like skeletons. All of them work, all of them give structure, but you need some muscle. And that is in the tools and the way you apply them. So if you aren't applying the tools in a considered fashion, what you end up having is you'll go through this and you'll just be checking off boxes for doing activities. Again, you'll say, oh, we established a team. Yeah, we described the problem. Yeah, we did some kind of containment. Yeah, we did a root cause. But, if you scratch, if you dig into it, you start realizing, oh, wait a second, how did you get to this? You're just kind of going through motions. So again, I hope to give some insight tonight and like ways that you can, actually get in and dig deeper. So tonight, we're just looking at one particular phase, which is the root cause analysis part. So I am specifically not talking about anything related to, problem definition or to like corrective actions, implementations of those kinds of things, long-term maintenance. I have to confess, I really do want to say a little bit about problem solve or problem definition. Problem definition is so critical, because if you don't have a well-defined problem, pretty much what we're talking about is not going to work. And one of the more common issues with problems is if they're not defined at the level the team is working at. By which I mean, I personally have never solved a, how should I say this, like a budget problem. I go in there and like, we can't meet our budget. Well, okay, I'll go in and help. And I'm going to solve the technical problem. And by solving the technical problem, the consequence is that the budget problem gets solved, right? So if the problem is defined as a budget problem, I'm not the guy to fix it. It needs to be defined in the terms of what I can go and fix. Now, again, I'm a person who is who's been called in to help this kind of thing. And so, I'll help refine the problem definition so that it is something that's suited to what it is that I deliver. But that's one of the things. The problem definition has to be suited to the team that's actually working on it. So, but again, this isn't to talk about problem definition, another of my favorite topics. So I'd like to do a little exercise with you all. And so you can see we have a deck of cards illustrated here. And what I'd like to ask of you, each of you, is if you will take and write down 6, there's a card I'm going to reveal, but can you take 6 guesses at what that card might be? So this is a, poker deck, 52 cards, no jokers.
Disconnected, ready to connect.
So again, just I'll give you a moment to write out. So again, you could say ace of spades, queen of hearts, whatever, but make a list of 6. Everybody ready? I'll give a few more seconds. So again, just 6 cards. Okay, so let's continue. So how many, is there anybody out there, okay, and you can put this in the chat, that has 8 of hearts on your list? How many people do we have in this? We had over 40, right?
47.
Okay, so somebody's bound to have 8 of hearts in there. All right, so Alan Bartnick has 8. Is it your first one? Oh my goodness. So we now know that Alan is our #1 problem solver, right? Because he, out of all those 52, he pulled the right one out. And so this is being a little bit facetious. It's probably he was really good at guessing today, but the probability of identifying one of those 52 cards correctly, if you make an educated guess, it's about 11%, right? So 6 out of 52, and again, that's with 6 guesses. So it's always happens that somebody in the class can get that accurately. Often, I'm surprised how often it's the first one, but and I'm using the term I'm using the phrase educated guessing advisedly, because based on what your knowledge, your experience, and so forth, you bring that all together, and when you look at a situation, or you get a list of symptoms, you based on what I see, this is what I think it is, right? That's just guessing. And again, it's educated because of the fact that you do have an education, you do have experience, right? So in this case, we all know, I think everybody knows on the call, the 52 cards in the French suit deck, right? So a French suit has the hearts and the diamond and the spades and the clubs. You have the 2 through 10 number cards. You have ace, jack, king, queen. So we know the limits of this. So again, it's an educated guess. Now, using the process of elimination, with 6 questions, you have basically 100% chance of identifying what card it is. So we're just going to walk through that right now. Well, before I get there, let me say this. The process of elimination is a strategy. It's not a tool, right? So it's a way of doing things, and we use tools to execute it, right? So again, if we think back to the framework, it's going to be the way that we execute the root cause analysis, or at least I'm going to explain how to execute for the root cause analysis step. So, but in and of itself, it's not the tool. We have to use other tools to make this strategy happen. So here we are we're looking at all 52 cards. I've got them, sorted here by their suit, by their color, I've got them ranked. And when we look at this, the first, how can we divide this up? Now, almost always everybody makes a split on color. So we'll start with color. I'll say, well, we're going to pose a question. We're going to do a test or whatever to figure out, is the card red? And the answer is, well, yes. So automatically, we have eliminated all of the blacks. And that means 26 of 52 cards are off the table. So it's pretty fast. Now, we got another question, right? What can we do now? Well, we could look at it and say, well, I've got 2 suits. That seems like the easy split. So again, we'll ask the question, is the suit diamonds? And then, do whatever it is that we need to evaluate it and figure it out. And the answer is no. And then we get rid of the diamonds. Now we're 39 of 52 of the possibilities have been eliminated in just 2 questions, right? We're just racing through the possibilities. Now, okay, third question, right? So we're looking just at the hearts. Well, let's split it in half, right? So see, which half could it, is it not in? So now we ask the question, is a rank greater than 7? All right, do what we have to do to figure that out, whatever test it is we run. And then the answer is yes. So we drop 6 more cards out of the possibilities. So that means we've got 45 of 52 cards eliminated. So that's in just 3 questions. Now we go to the 4th, right? So we're going to continue, right? Let's split this in 2. Basically, is the rank greater than 10? So basically, is it a letter card or not? And, do what we have to do to figure that out. And the answer is no. So what does that mean? Got rid of 4 more cards. We're at 49 of 52 cards eliminated in 4 steps, right? When you're down to 3, you can start guessing, right? I mean, the process of elimination, the splitting we're doing, that it doesn't necessarily have to be that way. But we're going to go one more, right? So number 5, we are going to say, well, is it 9 or 10, right? I've been splitting trying to reject the upper side. And so is it 9 or 10? And we do, perform our study or experiment or whatever. And then the answer comes back no. And so we've eliminated 2 more cards. We've eliminated 51 of the 52 possibilities in 5. Now I promised that it was doable, 100% guarantee in 6, but, in this case, we were able to do it in 5. Now, if you did exactly the same way I do it, you'll get it in 6 always. If you do the splits slightly differently, like if you do it letters versus cards, sometimes it takes 7, right? Instead of doing it by rank. But it's really fast. It's really fast, right? And every step of the way, as you observing this, you say, oh, okay, yeah, I'm following along. I know what's here and I know what's not. That's really powerful. So just looking at this, and the decay in the numbers that you have, if you look at it, the first step here, going from, 1 question, right? By guessing 1 card at random, you basically eliminate 1 out of 52. Whereas if you use the process of elimination, you eliminated 26. That's a lot of work that you're not going to have to do to assess, something that we can quickly eliminate, right? And then the second question, right, eliminated 13 using the process of elimination, but the educated guess eliminated 1 more. So now we have 2 that we've eliminated using the process, using educated guessing, but we've eliminated 39 using the process of elimination, right? So it's incredibly powerful. And this is really applicable in cases where, there's a lot of possibilities. Our job is to try to reduce the number of possibilities so that we can work on this, because the more that's out there, the more burden it's placing on us, psychically as well as in terms of resource. So, this is really important when there's a lot and you're trying to figure out many possibilities. On the other hand, when there aren't very many possibilities, educated guessing to me is, quite appropriate. It's because, here, if there's 4 possibilities, you really don't get much of an advantage with the process of elimination. It doesn't give you a lot. And to me, the key to that, the key to get here, most of the time, most problems don't have that many possibilities. The way that you make sure that you don't have that many possibilities is, you get out of your chair and you go to where the problem is and you lay your eyes on it, right? So this goes back to our dear friend Sherlock Holmes, because what would he do, right? One of the things is he's the master of disguise, right? So he would disguise himself so that he could go make observations without disturbing the scene, right? As a, he'd dress up as a, what was it? A livery man or something, and go so that he could make observations, again, without disturbing the scene. So if you look at what you do is you go and you observe, a lot of times, I mean, it's kind of amazing how often just getting up and going and looking can put you in a place to quickly identify the root cause. I mean, just, it can't be overstated. Go take a look, okay, please. But as I said, many problems are actually in this class where there's not that many possibilities. Again, if you get up and go look. So, we just did the poker card, and we're not going to present it in that fashion to, to a customer or whatever, to our leadership. We're going to do more of a, a slide report, kind of like what you're looking at right now. And how would we do that all on one page instead of going through, 5 or 6 pages? So we use a tree, right? This is a pretty standard approach to it. And the great thing about the process of elimination is that you're building in context. That is one of the most aggravating things when you're working with teams, that they know their subject very deeply. I mean, it's what they live and breathe all day long, and then they'll make reports out, they'll report out to whoever, customer, their leadership, and they'll say something and it completely lacks context. You're like, I don't understand what you're saying because I don't understand what you're referring to. In fact, I kind of had that same experience with my 16-year-old son a couple of days ago, where he starts talking to me about something, and I'm going, I have no idea what this refers to. And I'm having to stop him and saying, what are you talking about? I mean, I understand the words, but I have no idea what it's in reference to. So when you do the process of elimination, you basically say, hey, I've got this group, I've got this whole, and I'm going to do some kind of test so I can get rid of some of it, right? So in this particular case, we're looking at the cards I know are red and black. So when I run this study that I'm going to do right now, right? I ran what is a red card, and the answer was yes. So I've eliminated black. Oh, okay. So we have the context, and the black is going to, we're not going to erase this. So as we go on, nobody's going to start asking, well, did you check, 4 of clubs? Well, obviously we rejected that in the beginning. So then we say, oh, okay, now the new whole, right? The new complete grouping can be split between diamonds and hearts. So again, we know the context. Again, we ask the question, is it the diamond suit? And we say, no, it's not. So we've eliminated that. Okay, then within heart, what do we have? Well, we have, by ranking, is it in the lower half or the upper half, basically, right? And so we ask that question, and we say, oh, okay, it's greater than 7, and we eliminate some more. But it's easy to follow. And again, it keeps the context because we know what the entirety that we started out with, and that we're hacking away at this. Again, we're just getting rid of stuff. And then, is it in basically a number card or a letter card? No, it's not a letter card. And then we get down to our last 3. And then is it 9 or 10? We get rid of that, right? So this is a way that we often document, because with the process of elimination, you can show, okay, this is what, again, the whole, the entirety. And then as I hack off things, this is where we're getting to. But it's not like somebody just shows up and says, oh, it's 8 of hearts, right? It's not like, well, how did you get to 8? What was your logic, right? So again, that's one of the great beauties of this, using this as your strategy. So one of the things that we did here, we had several measurements. What were those measurements? Just if you want to put it in the chat, I can see that. Well, I see there's only questions. Well, the questions were actually a type, were to perform a measurement, right? So I'll go ahead and say color, right? That was the first measurement we made. Was it red or was it black? So that's a measurement. category. So each of the suits, right, we have to be able to identify what suit it is. And we also need to understand rank. And so those are the three types of, three elements of this particular space that we had to be able to evaluate, right? And, I do want to point out that this is not, what we're looking at here, this set of cards is a French suit deck. It has 52 cards. It has the 4 suits. This is what we know in the United States, but there are many, many, many other types of suits, right? I have, I didn't do it here, but, I have something that's called a Neapolitan suit, and it has like swords as well as, let's see, they have clubs, and they have cups, and they have coins, right? Those are their suits. So these questions here wouldn't actually work. So that's one of the things that we have to be very careful about, is that when we're looking at the problem, the problem that we're investigating, we have to understand what does it encompass, right? What does it encompass? So I'm going to represent this graphically. And, I guess I should say here, for those of you who aren't familiar with the Shannon-Redex methodology, a lot of this comes from that root. I'm not using their terminology here, but, because I think it's confusing terminology, but nonetheless, it comes from that root. But one of the things that they love to say is, oh, we do not use, well, I'll get to it in a second, but they have a certain, opinion that I don't think is really true. So if we start here, let's graphically represent this. We have, what's the card? It could be black or it could be red, right? And we showed that it wasn't black. Then we could have hearts or diamonds. We showed it wasn't diamonds. It could be the upper or lower half. We showed it was in the upper half, and then, it was in the upper half or lower half in the next set. And then was it, 9 or 10, or was it 8? In fact, it was 8, right? So what we see here is a fishbone diagram. And so the thing is, again, if you've ever dealt with Shannon, they're really proud of saying, oh, we don't use a fishbone. But in fact, you need a model. That's super, super important. You have to have a model in order to perform the process of elimination. So it doesn't have to be built off the fishbone diagram, about this specific fishbone diagram, but you do need a model. Now, I do want to say something about doing fishbone diagrams. The common practice is that, you're trying to solve your problem. So you create this fishbone, and, maybe you use a 6M, and then you start, speculating on what the causes could be, and you can start populating. That's a really bad situation if you're in, if you have a very distressed customer, or a customer who has a power kick, and they come in and they see that, because then what they'll do is they'll say, oh, you've got like 25 things on your fishbone that could be possible causes. I want data on all 25. And we did say at the very beginning that one of the keys in what we are in our root cause analysis is that there is a root cause. There's not 25 root causes. Investigating 25 is incredible amount of wasted effort. And so, I highly recommend that, you populate these as you have, in a process of elimination form, because otherwise, as I said, depending on the kind of customer you have, you could be you could be digging a deep hole for yourself. And the same advice goes for fault tree analyses. Don't show them, at least don't show them to your customer, because that can give you a lot of extra work. So I do want to show there are some common fishbone diagrams. You can use them or not. I think they're more thought starters here. But as you say, hey, how can I split this? How can I set up my studies and so forth so that I can do elimination? Again, it's a model. None of these, is perfect. I'm more familiar, I use the 6M mostly, but I look at the others and I say, oh, I could see setting up around those, especially if you're dealing with ones that are very transaction process oriented, procedures, policy, process, people, those kinds of things, that really serve in a transactional process environment. So let's just do a quick summary. Yeah, problem is a gap between expectation and reality. The frameworks like DMAIC, A3, and 8D, they're skeletons. They're not muscles. So they all work, they're all good, but how you do them, how you execute them is the key. The process of elimination, it's efficient and informative strategy for, finding your root cause, or at least finding a root cause candidate, right? So we've shown you here, one of the big advantages for the informative part of it is it always keeps its context. That's one of the things, again, when people are just throwing things up, well, we did this, we did that. And it's like, well, why did you do this? Why did you do that? In the process of elimination, you said, I'm running a test so I can get rid of these out of my list of suspects, right? Versus here are the other suspects. And then you do need a model of the groups of potential causes so you can do this strategy, right? If you don't know how you're going to cut things, what the groups are to do the process of elimination, it's really not going to work too good. So, but again, don't worry about it. Try stuff, and it is an iterative process. So there's different kinds of problems, right? So I've got a list here. It's not every single kind of problem, but I think it encompasses many, many, many problems. So the first one, and I think a desperately how should I say, doesn't get enough love and attention are transactional processes, because, when we look at any kind of problem, it often comes back to something happening in the office. Right. If you run out of material on a production line, you go back and say, oh, well, there was something in the ordering process, which is, again, a service type process. So they tend not to be very glamorous, but I do think they have a huge, huge impact. So, transactional processes, there's whole companies built around them, insurance companies, finance companies, banks, right? Because again, it's all about information and service. And of course, we have it all over the place in our facilities. Even in hardcore manufacturing places, you have human resources, you have purchasing, you have all of these training activities and whatnot, data analysis. Those are all transactional. And the tool that we often use, if we're going to use a process of elimination in these, is like the process map. That's really, really powerful there. Problems of geometry. So, again, this is kind of classical manufacturing, right? So if you do molding of any form, injection molding, blow molding, whatever, casting, machining, 3D printing, anything where you're creating a shape, you have problems of geometry. And there, the tool of choice is like the multivariate. That's a really, really useful and powerful tool there. Of course, process map is valuable there as well. But you're really looking at, okay, what step in my process is creating this problem, right? Or my deviation from my drawing. There's ones I'm going to call geography, but this one is like a really big idea, because geography could be like, we're in the pandemic now, and you say, well, where are people getting sick, right? So that's like epidemiology. And so being able to trace those problems, we're looking at concentration diagrams, right? Maps. But this also applies if you're talking about components, like, if you get things that get broken, like, oh, you know what? I have a gear. Maybe you can see the gear off to the left, and it says, oh, I have broken gears. Well, does the gear break in the same place? That was actually a problem of geography, right? Because we're interested in location. And again, the key tool here in all of those cases is the concentration diagram. Then you have issues of algorithms. So more and more these days, right? Everything's smart, and things aren't getting vehicles haven't been built, things haven't been delivered because they don't have computer chips, right? And we have within these, of course, the software, and those have problems too, right? code review is not a recommended, root cause analysis tool there, because they'll always find something to fix. No code is perfect. But, doing a function model, process mapping, those can help you set up for your process of elimination. Then, you have biological type problems, right? So we're talking about anything from farming to pharmacology to medical diagnosis. Again, you're going to use a little bit different set of tools, but again, you might use concentration diagrams. I don't think you'd use things like multivariate, for example, but again, there's a different set of tools than you might use, say, for algorithm. Oh, process mapping is always in those kinds of cases. Bulk properties. So this is things like the material properties. So you could talk about electrically, maybe how conductive is it? Mechanical properties like hardness or strength. Optical properties like transmissivity or refractiveness. Think about something. What else? Hardness, optical. I'm missing something, but there are plenty of physical properties. Density that may not be satisfactory. And so, in those cases, I'm trying to think what was the tool I would be using for this. Concentration diagram might be a possibility, but I don't think so. The others that I would put in there, I'm going to go to it. I'm going to remember it when we go to the next list. But again, if you're just looking at properties, you're trying to say, well, what is going on between, one might be okay and one might not be okay. What are the differences? Oh, control charts. That's something that we would be following very closely with this. And then we have energy transformation. And so with these kinds of problems, right, we can be looking at things like let's see, I wouldn't use concentration diagrams, but I'd be saying part swapping, like saying what's going on with one part versus another. You could sometimes use the multivariate, kind of depends, but mostly part swapping, sometimes looking at how the energy transformation is taking place. So again, those are the types of problems. And I mentioned a lot of the tools in here, but I also want to go back and just kind of repeat it with like Ishikawa's 7, right? This is something that we hear about all the time. Hey, Ishikawa, a long time ago said these 7 tools could solve, most of the problems. And I sort of agree with that, but I really think that he was looking at, manufacturing problems. And I tend to agree there with the qualification that you have a well-defined problem, which isn't always true. So, again, problem definition is number 1. But fishbone diagram, we just talked about that. That's a model of our system. We need to have that. We need to have that. That's if you don't understand like the elements of your system, you are in trouble. Stratification. This is super huge, right? So being able to separate like into groups, what are these things? And that can help us identify like and unlikes, where is and is not. So Pareto chart. Of course, Pareto chart is which one, what seems to be the big thing happening. And this is something that we will be using as we do the process of elimination. We want to focus on the big ones, the big hitters. Scatter plot. So of course, scatter plot, we're looking at a Y to X relationship. Is there one or is there not one? And control charting. So again, you're looking at, as I mentioned, with the bulk properties, like monitoring it over time. What's going on there? Oh, you could use scatter plot with the bulk properties as well, like saying, oh, we've changed formulations a little bit. What's happening there? If you, again, have the data. So the check sheet. I love check sheet, especially when you're trying to gather data from people who aren't really good about gathering data. Well, I once worked on a problem where they gave the operator a blank notebook and said, tell us when things go wrong. And it was still blank when I saw it months later. And so I ended up making basically a check sheet. I said, if you have this problem, you put, just put a mark and say who did it, what time, and so forth. And then, but being able to do that, within a couple of weeks, we figured out that we had a very serious problem. The chief engineer was like horrified once he realized, because he was just, saying, oh, you don't know what's going on. You guys aren't running your process correctly. But, with a check sheet, even if a person isn't very knowledgeable about how the system works, you can actually collect quite a bit of good data. So I like it a lot. And again, you'll find this could be helpful again in any of the process type problems that we looked at. Of course, there's histograms. So if you're generating any kind of data, any kind of outputs, the histogram can tell you what's going on. It's like perhaps if you're running a process, for your insurance claims, like how long does it take to get work done? Well, then you can see, is it a small distribution? Is it a wide distribution? Again, that's really, really informative. So now there's a few more tools that I'll throw into this. Concentration diagram, we've talked about that a lot. But I love that tool. And then actually here, I decided I would put in John Snow's map of London with the cholera epidemic. It's really, really interesting. So then, of course, a multivariate chart. And again, if you're working on a process, multivariate chart, like a machining type process, you need to be using multivariate charts whenever you're looking at problems. Process map is, again, one of those essential tools. Everybody needs to know how to do process mapping. And by needs to know how to do process mapping, one time I was coaching a team, and we had a terrible problem with excess shipping costs. And they showed me a process map of the process that according to how it was in the documentation. And I'm like, how are you losing $250,000 in shipping costs if everybody's following this process? And they're going like, oh, no. If they follow this process, everything's okay. It's that they don't follow this process. Oh, well, that's what the process map is for. What's the real process? So, we pretty much figured it out. Was everybody had the shipping number, and nobody should have it. So, and finally, we have part swapping, right? So if you're, again, if you're working on a car, and this kind of thing is like, hey, this thing seems to be okay, this thing doesn't. Well, let's swap the pieces and see if the problem falls, from one car to another car. Does it follow the part? So this is a very powerful tool. So we're going to do a little example of the process of elimination, right? But let's go through these steps. The first step is, what's the pattern that the bad Y is showing up in? Okay, because this is key. Then when we look at that pattern, we're going to figure that out by using a family of variation analysis. Then we pick a family that gives us the best leverage for figuring out, like, hey, we got good ones, we got bad ones. Then, we just apply a tool that helps us make the eliminations. And then once we figure out what the candidate for the root cause is, we should test it, right? Just to make sure, hey, I can turn the problem on, turn the problem off. So I decided the example I came up, pretty simple one. It does not have 52 potential causes. This is like you have a stereo and you're hearing buzzing when it's playing, right? So what you expect out of your stereo is a clear sound, right? And then what you're really getting is a sound with some buzzing. So that's not okay. So what we want to do is we want to look at families of variation, break down what's the pattern. Again, if we figure out what the pattern is, this gives us a lot of power. In fact, this is what distinguishes strong root cause analysis practitioners from everybody else, is they're able to do this, breaking out what is the pattern that the bad Y presents itself in. And if you ever used to listen to, Click and Clack, the Tappet brothers, back, long ago when they were on NPR, they'd always be asking questions, trying to isolate what is the pattern, right? So that they could figure out over the phone what was wrong with somebody's car. So the smallest, you want to work from the smallest that you can. And the reason for that is we're trying to limit the number of possible X's, because remember I said, if you only have 3 or 4 possibilities, you can just use educated guessing, right? You don't need to go through any big, process. So if we can get it down to like, oh, there's only 3 possibilities, well, let's just do 1, 2, and 3. So we'll start there, and then, we'll gradually increase it. Another way to look at this is when you talk about family variations, like, okay, I'm going to start from one knuckle to the next knuckle, same finger, and then one finger to the next finger. Like, let's say I have joint problems, right? One finger to the next finger on the same hand, then hand to hand, then, me to my brother, and then, brothers to sisters, and then, cousins to cousins, and then, second cousins and so forth, right? So you're trying to incorporate more and more, looking for when do we see bad ones and when do we see good ones, right? So point to point, same song, right? Maybe in certain passages it's not okay, and others it is. And then maybe song to song, maybe certain songs are bad and other songs aren't. Same speaker, and then speaker to speaker with the same source. We're going from the turntable, we going from our internet radio, and then maybe different source to source, right? So we build up this little groupings, and then we go through and say, what observations do I make? Do I need to run a test and get some results? Because sometimes you do this and you don't have data. And then we have to come to some conclusion. So here, if we say, okay, I'm listening to a song where I hear buzzing, and all through the song, buzzing is constant. Okay, what's my conclusion? Well, the red X is, I'm not sorry. The root cause is only at the bad level. So we can't really find it very easily. And then the next, we tried, okay, two different songs. Maybe we play a very soft, string quartet music, and then we play, death metal. If it's present in both, what does that tell us? Well, it's not coming from that. And then we check the two different speakers, and we say, wait, it's only in one versus the other, right? So what does that tell us? The root cause is at its bad level in one speaker, and it's a good level in the other speaker. Okay, this is helpful. And then, if we look at playing it from the turntable, playing it from the internet radio, well, the buzz in that speaker is still there. So what are we going to say? It's only at the bad level. So we've narrowed this down. Yeah, let's go through and attack this problem. The first thing is, and we check the measurement system, but we checked the measurement system before we started the root cause analysis, right? That's actually a step ahead. And so we perform a repeatability test, for example. I don't think there's a need for a gauge R&R or a Uden plot or such things, but just play it and see. And so we eliminate the measurement system. So we think it's okay, it's in the stereo. And then we've done this analysis of this, the families of variation, and the family variation with the contrast that we saw with speaker to speaker. Okay, now it's probably, the most likely place for a problem in the speaker is inside of the speaker. So I want to see if I can eliminate the speaker right away. And how am I going to do that versus the rest of the stereo? Well, I have a good speaker and I have a bad speaker. I'm just going to switch their places. So I'm going to unplug it from one, the one that's good, and I'm going to plug it into the side where that's bad and all its connections. And I'm going to take the bad one and plug it into all the connections for the good one and see what happens. Well, I do that, and my good speaker is now bad and my bad speaker is now good. What does that tell me? It's not the speaker. So then, okay, it's not the speaker. It's got to be someplace else. Well, what's the next most likely thing? Because again, I want to get, if there's, the most suspicious ones, I want to deal with them first. I want to try to eliminate them first, because if the most suspicious ones, I can be gotten rid of, then I'm going to have confidence that I'm making, how should I say this? I'm going to have confidence that the ones that are normally the problem have been eliminated, or I've confirmed them and I go after them because I know a lot about them, right? So in this case, I've eliminated it. So it's got to be in the rest of the speaker. And so in this case, the next really likely thing is it's in the cables. So I'm going to just swap the cables from one side to the other side. So I put the good one back where it belongs, good speaker back where it belongs, back the bad speaker. So it's the left and right, I put back and left and right. And then now I'm just going to take the cables and completely disconnect the cables and put them, what was for left speaker, I'm going to use that cable and connect it to all the right speaker connections. And what's on right speaker cable, I'm going to put it all the connections for the left speaker, and then run a test and see what happens. And then I do that. Hey, it's following the cable. And so what are we going to do here? Like, I'm not a cable manufacturer. I'm somebody who has a stereo. So I know what I'm going to have. I have a corrective action, get a new cable. And then when I put in the new cable, I want to confirm that it is in fact the cable. So I'm going to put the bad cable in, put in and see, is it still bad? And then put in the good cable, do it a couple times. Like, yeah, the bad cable stays bad and the good cable becomes good. So that confirms that, yes, it was a bad cable, but that's a corrective action. That's actually not a preventive action. Because if we look at this, well, why did the cable go bad? And we'll want to take it one step further and we'll say, oh, is it damaged or is it defective? And we'll inspect the cable and we say, oh, we see it's been pinched. So there's some kind, it's not defective. It's that there was some kind of damage to it. And then, a preventive action is how are we going to protect our cable as we go forward? So this is, this is the process that we would be following. Now, it's time to wrap it up. So the key point that I really want to amplify here is that the process of elimination is about elimination, right? Even when you have a suspect, what you want to do is run a test to get rid of them. That's one of the keys here, is that we want to try to eliminate. We're not trying to get to the root cause. We are trying to eliminate all the things that aren't the root cause. There's a lot of learning in that, because we know, if we know what's not important, we don't lose time investigating them, So, yeah, but of course, let's put on top of that, if there's a frequent group that is the most suspicious, we want to try to eliminate them first. We may not eliminate them. We may just confirm that, yes, the red X is there, but we've tried, okay, because we're trying to eliminate. With undisciplined, inexperienced people, what you'll find is you'll do like the first step of the process elimination, like you'll get rid of those 26 cards, and then they'll start guessing again. It's like, stop, we're doing this, because we need to get down to a small number. So we narrow the family or the suspects with the family variation analysis. That is, as I said, it really separates strong, root cause analysts from everybody else. If you start breaking down where the problem exists in both, where your bad X is in its bad state or the root cause is in its bad state and its good state, that gives you a lot of ability to focus and not waste time. So the type of problem that we face, it's going to dictate the tools. You aren't going to use the same kind of tools, for a geometry problem as you might use for a biology problem. Again, you need to pick the tool that suits the problem. Again, eliminate your suspects by likelihood. Put the high, the really suspicious ones, try to eliminate them first, because if you don't eliminate them first, then you might have saved yourself by eliminating everything else. No to date. I didn't say this, mention this before, but sometimes you make you make an elimination on a set of data, and then later it turns out the data wasn't so good. That happens. It's not perfect. No split is perfect. You work with the best data that you have, and you should be willing to reassess it. And so this does happen. And with the process of elimination strategy and using the tools and the reliable data, many of those confounding problems, they become ordinary. And I think that's what we get back to, Sherlock Holmes, when he says, hey, if you know my method, I'll just be very ordinary to you. And it's like, well, yeah, if you follow these steps, if you use these mental models, they can be very ordinary. So with that, I'll entertain questions.
All right, thank you, Keith. Your continual mention of suit kept taking me back to South Korea. I had a contract there in the mid-'80s and found that I could buy custom-made suits really inexpensively. So I went out and had one made, and I came back and tried it on and looked in the mirror. And I noticed that the shoulders came out a little bit, and then they would suddenly drop off. They would drop off at about a 45-degree angle before they actually went down the arm. And I pointed out to the tailor, and his solution was, if you don't look at it, it won't bother you. And so that is another way of eliminating the the cause of the problem. Ignore it.
Yes.
Unfortunately, I think a lot of organizations do that. Anyway, so folks, if you have a question, either unmute yourself or put your question into the chat. I thought we used to have a raise hand function, but I don't see that this time.
It's actually under reactions.
Okay. All right, so maybe raise your hand if you want to ask a question, and Arvid can unmute you.
You can unmute yourself, I think.
All right, so who has questions?
Jason?
Yeah, I do. So Keith, this is Jason.
How you doing, Jason?
I'm good.
Thanks
How
for
are you?
joining.
Yeah, thanks for inviting me. So is it fair to say then that the process of elimination is a lot like attribute separation, right? Sorting through attribute, like a gauge, if you will, whereas like variables, I guess inspection would be kind of getting into each one of those and saying, well, how much of this is potentially a cause? Because I love what you've said. The purpose of process of elimination is to quickly get down to the nitty gritty, to get to the biggest, most potential cause of the problem, right? Because you could always have various levels of problems introduced from all the X's, right? And I think like a variables investigation of that would be, well, how much is this contributing? And that's kind of where I get too complicated and overwhelm myself, right? So I love the idea that the process of elimination is like almost attribute inspection, if you will, right? Does this have this attribute or not? And then you move on to the next attribute. Is that a fair analogy?
I like that conceptualization, right? You say, hey, I'm going to do some kind of test to say, is it this or is it not this, right? And so if you look at it from the terms of the attribute where, okay, I'm using a plug gauge, it's big, it's on, you can kind of take it with that mentality, right? Because the objective is in the same way, but now I'm saying rather than doing it part by part, you're doing it by bunches of causes versus bunches of other causes, right? And the key thing, I didn't really talk about it, but I'll emphasize it here. The reason that we believe there's one root cause is because it's we're talking about variation, right? The outcome has variation, and the way variation of all the inputs, right? All those X's have some level of of variation. But variation, if you're doing a stack up, how do we add it? We add it by the square root of sum of squares. So if you attack a small, if you like, oh, I'm going to reduce the variation on this particular input, but it doesn't have much effect on the output, you'll never even know that you did anything because, its effect is so attenuated relative to what is the big source of variation, our root cause.
Attenuated is a great word. I was thinking, kind of in terms of like a DOE, right? I mean, how
much? Yeah. I mean, the idea is exactly the same. I mean,
right.
the basic concept, the same idea is there. It's just, okay, how are we going to get to it, right? Are we going to run a DOE, which is a tool we could use, right? So I didn't include it. I guess I should have, but it is one of those tools where if you're down to a very few, you would want to run it because we don't want to run, a 14-factor design of experiments, that'd be murder.
Thank you.
Your multivariate chart gets at some of that too.
Yeah, because it's basically it is in its own way a designed experiment.
I actually analyze small experiments with a variability chart, which is similar to a multivariate chart.
Oh, okay. Are there any other questions? I guess I should say I've given a copy of the presentation with PDF with notes, with all notes I added to it, so it's like a small book to Arvid so that he can be shared, I guess, on your MyASQ, and then I will also share it via LinkedIn.
Very good. Yes, we'll get that up in a couple of days. I got to get my IT guy He wasn't able to attend tonight, so I'll get with him and get it up, but appreciate it. We'll also have the recording on our YouTube channel when we get that worked out. I'm working out some kinks on that one.
Okay, perfect.
I'm going to stop the recording now.